Okay. Hello, everybody. It's March 22nd, 2023, and I'm Gary Bergcross, co-chair of the 2023 Ontology Summit, along with James Overton, as you see here. Um, this session will be sort of a catch-up and can follow up on a WikiData discussion. And unlike most of our sessions, we had one session on Tuesday because the OVO Academy was having Andrea and Tiago present on that very topic just around the time that we wanted to be presenting on WikiData. And so this is a follow-up. So what I have tried to do here for people who didn't attend is have a few slides from their presentation, and then it'll be followed by some slides that I have had from a prior presentation, a session at Earth Science Information Partners, ESIP's um, um, conference or workshop, where we had a discussion of this topic for the earth sciences, and I was part of that. And I'll use some of those slides. We should have plenty of time for follow-up and discussions along the way. And people who might have participated in yesterday might have additional things to say and to add. This first slide reuses some of the information from Andrea's introductory talk, and it gets sort of at the roots of Wikidata as coming out of the family of wiki products, Wikipedia, and some of the challenges that people had with that as a resource, particularly because there are different sources in different languages. English has the most in most particular areas, but it became difficult for efforts like the gene ontology work and their paper to sort of reference everything. There were linked databases as part of the paper and what's on Wikipedia and so forth. And so it was a little bit frustrating being trying to manage this thing as articles and data were updated. And so while Wikipedia is a great source, the idea of having something that sort of crosses languages and allows you to get at relevant data would be of value. This is one of my slides, and it's a context for part of this from a previous ontology summit where we were talking about knowledge graphs as a very useful semantic resource. And as the slide sort of has three parts going across. At the top level are the variety of sources that might go into making a quality knowledge graph, which includes unstructured and semi-structured information, to relational databases, which are highly structured, to other types of structures that can be brought together. The level below that is a semantic level, where with the idea of trying to integrate this data, making it cohesive in terms of meaning and relevance and so forth. And the bottom level is just the idea of building the knowledge graph out of all of that. So there's a lot of challenges here, and data integration is part of it. Wikidata would be one of these quality resources and might have alignment with other wiki sources. So Wikidata was started around 2012, and this is a biomedical example that was used yesterday. And I'll go through this briefly, and then I have another one to give you a little bit different view of what's in Wikidata. Um, the slide also includes the idea that Wikidata is very much a community and a hub for building knowledge resources around a community. Of course, the OBO Foundry is also a community, and so the idea of a variety of communities are trying to get together and share things over time, align them, and make them compatible. What this slide shows you is a page from one particular biomedical item. They're called items, which is ribotenic acid receptor alpha, or RARA, which is an alias, which would be in here. So in an individual page, you have a label and a header, and then you have something that's called a descriptor, which is not quite a definition. It's looser than that, but here you can see there's a line here which talks about what something about RARA. The statements are like RDF, in that they're a triple, which is extended, includes the ideas of references and qualifiers. A typical qualifier is a date, we're very familiar with that from Wikipedia in general. This item relevant to this particular date, a birthday, for example, or when something was published. A very important part that was alluded to before was the idea of different language pages. So down in the lower left-hand side of this, we have different sources of Wikipedia pages, essentially in different languages. That could be a source on RA. Okay. Now, this is a slide that wasn't actually shown yesterday, but I think they might have provided the link. It's a very useful summary. The link to it from WikiData itself, a one-page item on WikiData itself, is below. And I'm just going to talk about what's the information that's on the left side to give a better feeling about what's in a particular WikiData page. Starting with the idea of the triple, the item property value example. They use an example of Madame Curie, which is an item in Wikidata. There's some relationship, a property, and of course, there are many, many possible properties. If you read something like Wikipedia, uh, properties or relations are much better controlled in ontologies. They're looser, as are the descriptions in Wikidata. But in this case, we have one property. Marie Curie has a field of work and it has a value of chemistry. There are identifiers for each of these, a Q number and a P number. So, as they say down here, going down, the idea is that the descriptions and the aliases, RA was an alias, are human-friendly, language-specific strings, but recognizable to humans. Statements include identifiers, cite the links at the bottom of an item, which I've mentioned before, and one important one would be time. These uh, qualifiers add details to the claims, dates, and distinctions, and then a very important aspect I won't go into is the idea of copyright. What can you sort of put into Wikidata, and what can you expect to find in there in terms of how it's copyrighted? So their example of Marie Curie with a different relationship here um, is below in a statement. The property you're looking at is award. Maria Curie received an award, which was the Nobel Prize in Chemistry, and then it's qualified by a point in time. Okay, so this gives you an example, an idea of typical content to a page. Now, this page, I want to take a little bit more time on. Um, there's a lot here, and it's actually available on YouTube. The bottom link down there has a discussion of all of this so that people investigated ontological issues in Wikidata. It's obviously very interesting to this community. We didn't go into it too much in yesterday's meeting, but one gets an idea about it. So I'm going to talk a little bit about some of the stuff that's on the left side, and I will also pause and let people comment, ask questions about this since it's very central to I think the summit aspects of this. So some of the issues that people have found when they've looked at that, and I will actually have my own a little bit later in smaller amounts. Semantic drift. So that includes the idea that an item might come in with some particular meaning at one time, and over time it evolves. It could evolve for good reasons, that the science moves on, our understanding moves on, or it just could evolve because the community grows larger and another portion of the community has a view on that and sort of has some different meanings they want to put in there. So structural bugs come in a variety of forms. One is the cycle where an item, a class, if you will, A, might have listed as a subclass B, but elsewhere B is listed as a superclass of A. So there's a cycle between these two, and there needs some taxonomic class or clarification to work that out. There also is the idea of mixed up meta levels, where you have a familiar one, which is you have something that is an instance versus a subclass for a particular item. Redundant classifications. An item is talked about as an instance and as a superclass. Redundant generalizations are possible. A big one, of course, is the upper level ontology is messy. So they have some 59 subclasses within their upper level ontology. This is difficult for all ontologies, but it's particularly messy here and doesn't necessarily relate to other ontologies. So let me pause for a moment and see if anybody has a comment or a question on this. Let me stop. Actually, I can stop the share, see if anybody has their hand up. I see there's one item in chat, something I missed when I did. Okay. We have in there the other SOAP hub. Any comments or questions on this at this point? If not, I will go on. Okay. I have on this slide something of a difference of opinion. So this ontology issues in Wikipedia makes the argument that WikiData is sort of an ontology, but it's not based on OWL. However, one of our presenters yesterday, Andrea, said WikiData, and I think I'm closer to this opinion. WikiData is not an ontology, but it's simply a proxy for some semantic things. As long as reliable references exist, there's room for disagreement on particular Wikidata. And of course, the idea of semantic drift and some of these other structural bugs, for example, cycles and things of that nature, get at that. There's more on this at the links below, and I invite people to try those. Here's another slide from yesterday's presentation, just to show how connected parts of Wikidata, some of the data in Wikidata is to the OBO Foundry. They made a real effort as their community to sort of connect to items. So a variety of the ontologies are connected. And as it says down below, there are mappings from various ontologies in the OBO Foundry community to these items. There's also mappings, and they use something like the SCOAS types of matchings, such as exact match at a lexical level, exact match, narrow match, broad match, and so forth. One important point about all this, these difficulties of mapping, is that ontologies tend to use somewhat more strict relationships. And when you're trying to map between items, the question is really how it relates to the overall structure of an item within an ontology. So does it have the same superclass? Does it have the same subclass, for example? Is the description sort of make sense in terms of the axioms that are for a particular item? So there's a lot of challenge in mapping. That turns out to be a big activity. This is just a small example of mapping. You have a matrix, in this case from the vaccine ontology in the OBO Foundry, with a variety of items in there, the vaccine itself, and then various types of vaccines and description. So you can keep track of the mapping through this a spreadsheet approach, and some links to it are indicated at the bottom. Okay, so that's sort of my take on some of the core aspects of what was presented yesterday from the biomedical realm. So I wanted to leverage some slides I had available from a prior effort, which is part of the ESIP session, ESIP session. It was set up by Charles Vardaman and his associates, Albin, Jan, and Jane, who are indicated here. And I had a part of this and presented the back part of this particular session. So the title of this for ESIP was called A Knowledge Graph for the Earth Sciences, which is a question mark. I've added crossed off ontology because, as we said in a prior slide, Wikidata isn't quite an ontology, or if it is something like it, it's got a lot of issues as an ontology. So this particular session was aimed at knowledge graphs more than ontologies, but there was obviously some relationship. In a way, you can think of Wikidata being available in a resource in two directions. One, it might provide input to a more formal semantic item like ontologies. On the other hand, it might provide a lot of valuable input to another semantic resource like a knowledge graph. And that's what we were exploring in this particular case. This was the header from my particular presentation, talking about semantic harmonization. So again, it just starts with some of the basics on knowledge graphs for people who weren't as familiar with them. The idea, we know that they're very valuable for browsing, and a lot of effort is being given to them. One of the challenges is that there's diverse modalities and many diverse sources that you have to integrate, as I showed in the earlier slide. However, Wikidata does provide some opportunity for building knowledge graphs in the earth sciences as well as other areas. There are in the earth sciences, there are many resources available, but they are scattered and they're often only shallowly done, and they're inconsistent. But of course, Wikidata can also be inconsistent too, but it provides at least a starting point for some things. The way Wikipedia did provide a starting point for ontologies in the beginning, so that, for example, the suite ontology, developed a decade or more ago, imported quite a few items from Wikipedia at the time. This was before Wikidata was available. Okay, so when I looked at Wikidata, I looked at a variety of relationships that were available. There were many for the biological sciences. In the top third of this diagram, you have some of the last of the 167 or so relationships here. So you have some really strange ones, like a relationship for identifier of a fellow of the Royal Australian College of Surgeons, or a hospital ID from Board of Development Empowerment, and so forth. So these are not the type of things you would find in an ontology, but they are in Wikidata. Stubbed out here are relationships, properties for mathematics, geology, astronomy. And I have just a small example of some of the ones that are available for astronomy. But I was wondering about what the relationships might be in earth sciences, and we could import things from a variety of sources we have. There wasn't that much in the earth sciences in Wikidata as there are, say, compared to the biological realm. But here's an example of what Wikidata knows about an item called permafrost, which we're familiar with. It's defined there as soil frozen permanently, which in this case means practically defined for a period of 2 years. And below that, you can see the ideas of resources, not only in English, but in Spanish and other languages. There's nothing about in the description. It's not necessarily all we would want in a definition, such as we find in ENVO, the environmental ontology. It has nothing about the constituents of permafrost, which might include rock and ice and so forth, which is an important aspect of it. But we do find a range of things. We find this problem of instances and subtypes in there. We find some local definitions which may be useful to have. And we find a link to the UNESCO thesaurus, which has a taxonomic structure. So we understand this as part of glaciology. And we find lots of relationships in there in the thesaurus. So it's useful, as I say, if you were going to be building a knowledge graph of this, you could find resources that could help you sort of get a sense of the domain. When you query Wikidata, and I did for soil and for glaciers, you get a range of responses. There aren't that many locations for soil identified in Wikidata, but there's quite a bit of information on glaciers. And as you can see, if you're looking at, for example, the continental Alaska, U.S., on the west side of continental U.S., a range of glaciers and not much on the east in comparison. And you see around the world, it all makes sense. So you can find relevant data that you could use to populate a knowledge graph with this. And one other thing is that there are a variety of tools that you can use to essentially help you understand what is in Wikidata. And so I use this for soil. And so it comes back with a range of sources. It reports back on sources we have. It reports back on some of the qualities that are understood as part of soil, such as the fertility, the temperature, the pH value. These are not axiomatized, but at least that's a starting point on those. And they have a range of other relations. So it's encyclopedic compared to many ontologies. You can see that, where it's studied, which might or might not be an ontology of interest. It's a subclass of many things, including granular material, and it has some relations like opposite of, what is not. So you can have a disjunction here, for example, and it has parts. Okay, to finish up, again, I was taking the approach of what is this of value to what value does it have for knowledge graphs? And it provides a fair amount of relatively disconnected to some degree information, although you can use it as a starting point. It's one of the pieces of information that is available on the web. It's one of many that has diverse formats. So the integration of these data from different sources for a knowledge graph is difficult, it's challenging, particularly if you're trying to enforce some restrict semantics from ontologies. Some of the open questions are, can the knowledge graph efforts be integrated, or are we going to be building very disparate knowledge graphs with overlapping areas? So we're building silos at a different level now. And another issue is the need for common models, representation, and tools. And to finish up, I had more on this, but I'm not going to go into it here, is the question of what are we harmonizing if we're using it to build knowledge graphs as part of one of many semantic resources. And so just what I've done here is just taking the semantic ladder, a rough illustration of it, which has things like controlled vocabularies, which pretty much have strings and very weak semantics, to glossaries and thesauri. And I thought that WikiData sort of fits somewhere in here, maybe just below taxonomies and ontologies, because as was pointed out with one of their problems, their classes, subclass relationships often are very messy, and so you can't necessarily trust them, but it's a valuable source. And so with that, let me stop and we can get into a broader discussion and follow up on this. I will try to go out to the chat and see if there's anything there. I see my co-chair James has his hand up, so maybe he can enlighten us a little bit more.
No,
James,
I'm not going to enlighten. I'm just going to ask some questions. And
find people to answer them.
Yeah, thank you very much for the slides, Gary, and Tiago's here. Thanks for the presentation yesterday, Tiago. Yeah, so I mean, I have kind of I have a general question and a kind of technical question. I remember, I don't know, 20 years ago when I started using like Wikipedia, this like crowdsourced encyclopedia, I was initially pretty skeptical, and there are all sorts of stories about whatever crazy things going in there. But I have come to just rely on Wikipedia as like, if there's a new topic that I don't know anything about, it's a great summary to get started. And I've donated to it many times over the years. And then WikiData is also this amazing resource that seems to have so much promise, but I guess I don't know how to use it for the stuff that I do. So I understand the benefit of WikiData just as like backing the Wikipedia and supporting all those different languages and different like communities, helping them to coordinate. I understand that 100%. But then when in my work, which tends to be data integration, working on scientific databases, helping my clients like connect stuff up from one place to another, or just do quality assurance using kind of ontologies and reasoning. I guess I don't see how to use Wikidata for those things. So it has all these statements in it, and these statements have all this provenance, and it's coming in from all these different directions. And I guess I can also understand kind of the mapping use cases, but I don't want to do mapping. I want to know facts. I want to know the truth, and I want to have that like supported and justified by whatever provenance information. So is there something that I'm just not understanding? Is that am I just asking for the wrong things? I guess that's it. I don't quite understand how I can use Wikidata for science. and so I'm asking this vague question so you guys can help me out a bit.
Well, let's see if somebody offers some more help here. I would say that's close to my experience also. I may put a little bit more value on the community that is connecting to it. You can get to a community. And so if you, for example, look in parts of WikiData and say, okay, well, I see a lot of information here, but it doesn't quite make sense from an ontological point of view, a formal point of view. At least you can find out who's doing what there, who has data. From a knowledge graph, of course, is very valuable for the data. So as I say, I think it goes in both directions. One going to knowledge graphs, and it's not as worried about the semantic, the formal semantics of it, and the other going to an ontology as inspiration of saying, okay, ontologize this. Here's a starting point. So, unfortunately, a lot of us have a lot of work to do without having to take that on. So it's a question of priorities there. But it seems like to me, the OBO Foundry has made a noble effort to sort of at least keep track of things like mappings and so forth. But let's hear from somebody else and have thoughts on this. The only thing I was going to add is I've argued in other places and a paper or two on the value of light semantics and incremental semantics. The idea that it is okay if you start at a low end, as long as you're committed to sort of progressively increasing the semantics over time. But of course, that proves to be challenging if people create a mess and you have to untangle. Where do you start? Kai, it's good to hear from you. What do you have to add?
Hey, everyone. Thank you very much, Gary, for the talk and everything. It's quite interesting. I just wanted to ask or state kind of regarding WikiData, there might be certain utilities in WikiData that are actually better than things within OBO. Like, for example, I'm thinking of a gazetteer. Like if you needed to know, like a place, a list of places that exist, blah, 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 et cetera, gazetteer. I think WikiData, I'm not sure, I haven't gotten a chance to fully investigate it, but I wonder if something like WikiData might be a better resource than something like the OBO gazetteer, which I don't think is maintained, and it could use a little work if it were maintained. So I don't know, maybe there's places where WikiData and OBO Foundry ontologies kind of could complement each other within different data applications, like gazetteer being really an obvious example. Sorry, that's just some thoughts.
I agree that that's a good example. And maybe more generally, kind of for OBO is all about classes of things, and Wikidata is better at individual things, particular things. And so countries and cities and locations, Wikidata I can see could serve better there. Andrea might want to be replying to me. I had a more controversial way to put my question, but maybe she would like to speak first.
Ashaya?
Yeah, so
I'll give you a chance.
Thank you. I'm not turning my video because the light, you will see my face like totally black. So I want to share with you my experience. I think at least how many years ago, maybe 7 years ago, I was looking at Wikidata, and I echo what Kai just said, because I use Wikidata to pull out the zip code, county, city, and countries. And then I had very nice data sets that is clean and nice, which we cannot really pull it out from ontology. That is one. The second, I observed that in Gary's slide, it just showed that there is a modifier for a statement, which added time in there. And that is very difficult to do in our ontology, right? We can put more things like that, such as a time, to modify a statement. And usually we have to, actually. So that is a good thing. But I have a question to Tiago and Wikidata. So there are things. And I echo also, James said we need facts. So there are like the things that are listed on the Wikipedia seems like following a schema. And what schema, how do they decide the things are listed out there? Because they could definitely pull out things from the ontology if there is a defined, like for certain domains, if there is a defined schema or metadata being defined, then we can kind of do that exchange of data. But I still don't know the like thinking of Wikidata. How are they thinking of using it for some for like research or things like that? I think it's a good thing for mapping the different languages from different countries. That is certainly one use. Yep, I stop here.
Well, Tiago is here. He might be able to address part of this. Tiago, do you want to take it on?
Sure, thank you. I don't know how much I can answer, but Wikidata is largely schemaless. It doesn't enforce any schema on the data, on the information. It has a lot of information on individuals, as James was mentioning, but it also has a decent number of items about classes, about genes, proteins, and things like that. They were added by bots, and bots kind of set up their own schemas. So there's now a lot of people thinking about how to formalize schemas for subdomains of Wikidata, but as Gary was showing, it's this big elephant with different parts and different ways of looking at it. So I think that using Wikidata for research, considering schemas and structured things, you shouldn't expect it to be super consistent, and you shouldn't expect it to be fixed. But there are schemas being developed, some of them explicitly, some of them implicitly by the community and the way the people start doing things. I don't know if that's what you're asking, but maybe that helps.
I have
on the prior, I guess some of the prior conversation, I was just going to add that the practice that people find is that that sub-communities are interested in local structures, things that make sense to them locally. So they have an implicit idea about how things connect locally. It may differ from another a group's implied structure, and that's why the upper level is so messy. If you look down trying to sort of resolve some of those things, they're very challenging. But people are really interested in local parts, so that you could perhaps find consistency within a subpart of Wikidata based on the communities that developed it. Well, let's see. So I think there's yes.
So wouldn't you go back to the sources at that point that are going to be probably more highly structured? So if some bot imported a database into Wikidata and you went through Wikidata and you found a whole bunch of cool stuff, wouldn't you want to go back to that database and it's more highly structured source? All right, Diego's nodding. Okay, I guess that's one of the points he was making yesterday.
But some of the sources would also be not structured. Some of the sources would be an article, right?
Okay. I wanted to sharpen my question a bit to see if I can make people more upset. So with Wikipedia, I read an article and I, as a human, have a bullshit detector. So if someone puts some like stupid lies and vandalizes a Wikipedia page, I trust myself to mostly catch it unless it's pretty subtle. Maybe I don't know much about whatever the particular article I'm looking at, like, I don't know, My Little Pony, but I do know a lot about stuff in general. And so if things aren't lining up, my bullshit detector will go off. I am not a smart enough coder to write a bullshit detector in software. And so my worry is if I send a bot, I send an agent to look at a Wikidata page, it will not be able to tell if there's kind of bullshit mixed in there. And so I guess that's my sharper point. I trust Wikipedia for my use case because I'm a human reading it. And I'm not sure I trust Wikidata to send my software at it. because my software is dumb.
Yeah. Vincent, who also had a comment on the chat.
Yeah, I just wanted to say to James, take your bullshit from Wikidata, give it to ChatGPT, and you get bullshit for Wikidata, for Wikipedia. I mean,
bullshit in, bullshit out. Yeah.
Yeah. So I mean, trusting a text because it sounds reliable nowadays, it's no longer an issue, I think. And well, I had a question in the chat is, did anybody try to use these mappings that you have to between Wikidata and structured data sources like ontologies, taxonomies, whatever, to try to detect the problems and highlight the problems in the structure in Wikidata? Or in alignment, because if it's a place where different data sources kind of meet, because people say, oh, this is my concept, I'm going to map it here, and someone else from a connect field comes and put this concept in there. If we integrate everything and do some simple reasoning, we should be able to highlight the problems there. And once you found them, what do you do with this? So this is the next step. It's just like finding the mapping in the first place and then cleaning the mapping and agreeing on something. But maybe Wikidata is a place where one could open a discussion about this stuff, because otherwise everyone stays in his bubble with his own view of the stuff and with the elephant. So Wikidata would be the elephant, the place where people meet and try to align. On Wikipedia, you have, on some pages, you have very long discussions between the editors, changing back and forth the content of the articles. So I suppose I see this as a good thing. And does anybody know about an initiative to try to leverage this stuff?
Ashaya has her hand up. Go ahead, Ashaya.
Yeah, I think that's a good point, Vincent, because that triggers me thinking. I'm mapping Mondo, disease ontology, and HPO. I need a platform like Wikidata, if configured the way that I can put this one concept aligned with, and I have the Mondo sets of axiom of definition and the disease ontology sets of axiom definition subclasses, all those in one page. And then I can initiate some discussion from the domain expert. And then I could reach an kind of I don't know if there's an agreement, but we can somehow start from there. I do think that can be leveraged, Wikidata, in that way.
About who is working, Tiago, maybe with Wikidata directly, is there such a group there working on trying to leverage this external structured data source to make some kind of automated cleansing, or at least highlighting of the problems?
Yeah, sure. I don't know if there are a lot of wiki projects inside the Wikidata infrastructure. There are communities that get together around some topic of interest. There are some topical wiki projects like medicine, clinical trials and stuff like that. But there are some technical wiki projects. So wiki projects for schemas, wiki projects for ontology, and wiki project for technical things that go in the background of Wikidata. So I don't know if there is any one group in particular thinking of this situation as a whole, but the community has small discussion groups. We have a Telegram chat where people are all the time discussing about it, and there are constraints that you put in place on Wikidata and then detect some constraint violations. So they're not blocking, they don't block anything, but there are some ways you can set property and relation constraints that they are flagged to the community. Hey, these entities mapped to different items in mesh or to different items in the cell ontology, and it shouldn't be. So there are kind of in place structural mechanisms to help people to do this merging of other data sets. But I'm not sure if there's anyone thinking about this in the bird's eye view of how to to make the elephant better.
So it would seem to me that there are certain of these ontological problems which we mentioned, like confusing between an instance and a subtype, that is general. So you could catch that and you could give advice. You could at least, you don't know how to necessarily how to resolve it, but you could raise that as an issue to the people who've entered those items and try to resolve it.
I think this is this very point is very difficult, because when you say permafrost, it's an instance of this, but it's a subclass of that. It could be both at the same time. And in the ontology world, you would have a class and you had maybe an all named individual, and you know this is the end from this individual, and you might have it might be a nominal representation of a class. You could have this kind of stuff. So you can switch between the instance level and the class level. And but in the conceptual world, you have these kind of meta classes that are instances of a class, and it's both at the same time, and it makes it very difficult to decide whether at which level you are looking at the actual information.
And I don't think some of those things you can represent in OWL actually.
Well, what you can do in OWL is you can if you define a nominal class with only one individual in there, then you link the individual and the class in some way, and you can separate the two levels.
Yes.
But the thing is, if you go in an RDF data set, most of them are loosely structured, and you would have things that are lots of punning and things that are at everything at the same time. So
I see that Tiago has put a good reference in for people to look at here on this issue. It does remind me of the old issues about ontologies being precise, saying things exactly, but then you miss a lot of the encyclopedic knowledge that people have and want to know about. And so the ontology design patterns, to some extent, try to handle this by having some things that are core, and then you can build variations off of them. Oh, I guess waiting for another comment. Oh, James, you have one. Go ahead.
I was going to change the topic a little bit, so if anyone else wanted to continue this thread, go ahead. Otherwise, I'll segue.
Well, I was just going to add one thing about the value of this, which is provenance. You was basically, you can find out who has been saying that and go back because of the links. You can go back to where it appears. That's all. That provenance provides some value too, even though you're getting disagreements. Well, who said that and who's got data for it? But go ahead.
Yeah, no, that provides a lot of value in my mind, and in stark contrast to something like ChatGPT, where you have no idea where it came up with whatever it's saying. But I guess that does connect to the question I was going to ask. So there was a specific point in the chat yesterday about Nico was asking why like a certain thing an object was a literal and not a URI. And I think Tiago answered that just Wikidata is not RDF, and so there's some differences there. And I just wanted to ask if there's like a quick technical summary there. So I understand the Wikidata model as kind of like whatever, you have an item and then a property and then a value, and then you have some qualifier and then another whatever qualified value for it. And so that gives you, it looks a lot like RDF with reification, but I guess there's some differences there. So I don't know, is there a quick summary of that without getting too far into the weeds? I guess that's a question for Diego. Yeah, and then it's also, everyone is like, oh yeah, it's in Sparkle. So, okay.
Yeah, so Wikidata, I don't know exactly what's the kind of core way that it's stored. I think it's kind of complicated JSON structure. but it's parsed into an RDF and uploaded to BlazeGraph for the Sparkle querying. So in theory, it should be, you should be able to at least theoretically download an RDF dump of the whole Wikidata, and maybe you can do that. I'm not sure. There's a page for dumping the whole Wikidata. I'll find the link and put it here. But most of the information in Wikidata is in. It could be stored in RDF. So some of the information is not. For example, the exact people that edited each statement. This is not queryable in RDF. This is just a REST. You can query that in a REST API, but you don't have all the information Wikidata as a structured information, but the core statements, properties, and so on, they should be accessible in a RDF and interoperable with other RDF formats to some extent.
Okay, and so this specific difference was like in the values, which RDF would call objects, and RDF has literal, like plain literals, language literals, tagged literals, and whatever IRIs can be in the object position. And I think you're just saying that Wikidata doesn't do it that way. So that those
So,
like
yes, it does have many different types of data values. I think 17, 18 types or so. You have dates, you have quantities and texts and things that you could consider literal in RDF. And then in Wikidata you have links to other items, which are URIs, basically.
Okay.
And you kind of have
so
that
there's
somewhere.
Something subtle that I'm not getting, but thank you for that answer. That's not. I should just look up the technical stuff. Now we're just getting into my curiosity, but thank you, Tiago.
Something was mentioned in passing yesterday. Maybe Tiago can follow up. Is RDF star was mentioned as maybe a connector here, and Ken also has developed a standard that he might talk about, which he mentioned, I think, maybe in a comment, but he might be able to say more about that here. So, RDF star, anybody have a comment on that and how it might be related to this issue of how do you express qualifiers and such?
Well, sorry. Our perspective in OBO was that it seemed promising, and then there were some weird technical differences about how the statements are identified that don't quite map onto how we would handle blank nodes that kind of derail us. But sorry, Ken.
Yeah, you might look at AGSQL. I mean, the idea of an AGSQL is that it's basically reifies all of your edges. So it makes it possible to annotate anything. You don't have to go through a separate reification step, which of course can really complicate your structures. RDF star helps a little bit in this regard, but it doesn't allow all, it doesn't specify the reification of all edges, just basically property edges, data properties. So
can you provide a link to your standard?
Yeah, I have it published. It's published in the Journal of the Washington Academy of Sciences, and I can certainly send it to anybody, and I'm going to post it shortly. It's pretty complete. It has the complete semantics for the language. It even has a DOL mapping. So it specifies pretty much everything, and it's also backwardly compatible with Sparkle. So Sparkle queries would still work just fine. But now you can also put in queries where you specify the identifier of your edges. The language doesn't have any meta level. There's no ontology level for it. So it would fit those cases like, say, WikiData, where they don't yet have, I mean, they don't have too much in the way of an ontology. I guess, but they just have shapes. So this would be a way of dealing with it. The big disadvantage is that being just a single individual, I don't have the resources to actually build such tools. I don't have a tool that implements AGSQL. I just have the specification.
We're getting close to the end of the hour. Ashaya has a hand up too.
Yeah, it's just I'm wondering if anybody here knows about the relationship between we have Wikipedia, Wikidata, and the DBpedia. It seems like they can search across each other, but then I don't know how the data feed into each other. Does anybody here know about that? I take it as no.
I don't know, but I suspect that there's an effort to keep them aligned, but I don't know how to qualify that.
And Tiago had to go, so we won't have our
I
expert
think
answer.
what Diego said yesterday was that the info box in Wikipedia comes from Wikidata, and everything that is text is not in Wikidata.
Right.
Right. Hmm.
And what about DBpedia? No. Okay. But if
Okay, I don't know.
yeah, if you go on the Slack chat, we had a chat yesterday after the talk, and Andrea, he had a Sparkle query there, so you can search through using the Wikidata and then somehow get things from the DBpedia. It's cool.
Yeah, so there's some degree of alignment, but I don't know exactly what the data sources are for all of them. I did have a slide on the architecture for this, but I don't. It's a little bit dated, so I didn't really show it. And but that would help us understand the flow, the data flows, and what it's done to connect these things. Well, anything else before we end up here? If not, I want to say that we're going to have an interesting session next week with Martin Skevland from Oslo, who's created what's called the reasonable ontology templates, a framework for them. So it'll be a little bit more in the line of the ODP patterns again and templating. And after that, we're going to have a session on schema.org. So next couple of weeks should be rather interesting. So I look forward to those sessions, and I look forward to seeing you again. And with that, I think we can end our session here. Thanks for coming, everybody.
Thank you.
Bye.
Bye now.
Thanks, Gary.